Hello everyone, welcome back to learn the Axially loaded member. In this lesson, we will study the design procedure of a solid web Axially loaded compression members. For a solid web Axially loaded column, biaxially symmetric sections are generally adopted as sections of the member to avoid the flexural and torsional buckling occurred. In the previous lesson, we have introduced some common biaxially symmetric cross-sections used for a solid web Axially loaded column. These cross-sections include the hot-rolled section and the welded build-up section. When selecting the cross-section of a solid web Axially loaded column, the following principles should be considered. Firstly, the area of the selected cross-section should be expanded far away from the central axis to increase the moment of inertia and the radius of gyration as much as possible in order to improve the overall stability and the stiffness of the member. Secondly, trying to select a section having equivalent stability along with two main axis directions, thus satisfying the economic requirement. Third, the selected section should be easy to connect, has a simple configuration, and easy to manufacture. In the design, we need to select a trying section first according to the above principles, then determine the detailed size of the cross-section. After that, we need to check whether the strength, stiffness, global and local stability of the member satisfy corresponding requirements. Generally, when designing the cross-section of the Axially loaded compression member, the following conditions are known: actual compression force N in the member, design strength of the steel, supporting conditions at ends of the column, and the cross-section form. What the designer needs to determine is the detailed size of the section. The specific design procedures are as follows. Firstly, we can determine the cross-sectional area according to the overall stability condition of the Axially loaded compression member. We can first assume the value of the slenderness ratio lambda, and this value can be taken between 50 to 100. Then, according to the assumed lambda and the type of cross-section, we can check the design code to determine the value of the overall stability coefficient. Then, the required cross-sectional area can be obtained according to equation 4-12. Secondly, according to the assumed slenderness ratio lambda and the supporting conditions at ends of the column along the two principal axes, we can derive and determine the value of the radius of gyration along the two principal axes. Third, according to the area A and the radius of gyration Ix and Iy obtained above, we can determine the type of hot-rolled sectional steel. When there is no appropriate type of sectional steel satisfied with the corresponding requirements, we can select the welded build-up section for the member. The height and the width of the build-up section can be determined according to the approximate relationship between the radius of gyration and the section size. Fourth, according to the area A, determines the width and the thickness of the flange, and the height and the thickness of the web. Fifth, conduct verification of the determined cross-section. The corresponding verifications include the following points. Firstly, when the member's cross-section is weakened and reduced by a hole, verify its strength. Secondly, verify the overall stability capacity of the member. Third, verify the local stability capacity of member. Fourth, verify the stiffness of the member. In addition to the above verification calculation, the corresponding configuration requirements must be met as well. In this lesson, we have studied the design procedure of a solid web Axially loaded compression member. In the next lesson, we will learn the design methods and the procedures of build-up axially loaded compression members. See you next time.